Right, in this section we're going to add and subtract some fractions, and we're going to begin with the familiar setting of numerical fractions. I'm going to illustrate kind of our process with the numerical fractions, which you learned at some point along the way, and then we'll see how this is really analogous to our approach with algebraic fractions. So when I'm adding numerical fractions, I begin by factoring the denominators. I don't factor the numerators. I mean, 5 and 7 are prime anyway, but even if they weren't prime, I leave those as they are, and I factor the denominators, usually down to primes. And I do this because in order to add fractions, we need a common denominator. So I'll notice that my first denominator has factors of 2, one factor of 2 and one factor of 3. And my second denominator has a factor of 3 and a factor of 5. So the first one is missing this factor of 5. I'm going to add it in because I want them to have the same denominator. And I'm allowed to do that as long as I also add a factor of 5 up top. Basically, all I'm doing is multiplying this fraction by 1, because 5 over 5 is equal to 1, and we know that we're allowed to multiply things by 1. And then I move over here and do the same thing with the second fraction. This has to pick up this factor of 2. And I'm allowed to do that as long as I multiply by 2 up top. And so now we have 25 over 30 plus 14 over 30. And if you have a common denominator, you just bring that denominator over and then you do the operation, in this case addition, on your numerator. So 25 plus 14 is 39. Now at the end, we have this fraction as a result. At the end, you always want to make sure that your fraction is reduced, is simplified. In this case, as it turns out, we can factor out a common factor of 3. We can cancel the factor of 3 and we get 13/10, and we leave it like that. So this process works the same way with algebraic fractions. We need to have a common denominator. Now in this example, 320, we already have a common denominator of ax. So that means I'm ready to add them. And I'm just going to do the operations indicated, this addition and subtraction, on the numerators. So I've got b plus 1, and now I just have to be careful with my signs here. I'm subtracting 2b minus 1. I'm subtracting the entire numerator, so I need to use parentheses. So this is b plus 1, and now I'm going to distribute that negative, minus 2b plus 1 all over ax. And now combining like terms, I have a minus b plus 2, or 2 minus b over ax. And that is as far as we go. In our next example, we don't start out with a common denominator, so we need to get one. We need to obtain a common denominator. But we don't have to factor anything. Because there's no addition or subtraction within the denominators themselves. So I'm going to start out actually just by rewriting this. I'm going to leave myself some space in between the fractions. And so what I want to do is just go through and add in factors that are needed in order to bring us to a common denominator. So this first fraction needs to pick up a factor of s cubed. And I can add it in as long as I also multiply by s cubed up top. In the middle, this has to pick up, it needs to pick up a factor of 3. It's all set with the s's, but it needs to pick up a factor of r so that we're raised up to that r squared that we have there. And at the last fraction, this has to pick up a factor of, it needs an s squared to bring us to s cubed. And it needs a factor of r squared. So now our common denominator is 3s cubed r squared. And up top we have, let's see, a 2s cubed plus 12r minus 5s squared r squared. Okay, in our next example, again, we're starting out, we want to add these fractions, we're starting out without a common denominator. So we need to obtain a common denominator. And again, I'm going to start by writing the fractions, giving myself a little bit of space. And then I need to figure out what factors each of these denominators needs to pick up. So my two factors that, my two denominators are x minus 1 and x plus 1. And we have to realize that those are completely different denominators. It's like having a factor of 2 and a factor of 5. They're just different. So the first denominator needs to pick up the factor of x plus 1. And I can do that as long as I give it an x plus 1 up top. And the second needs to pick up a factor of x minus 1. Now, having done that, we could see that our common denominator is x plus 1, x minus 1. And this is, in fact, the least common denominator. And up top, I have a times x plus 1 minus a times x minus 1. So now, we've got a little bit more work to do. We have added them. And the denominator is expressed as a product. Leave this factored. It's not that you're not allowed to multiply it out. You are allowed to multiply it out, but it does not get us anything, and it can sometimes make our work a lot harder. It can make our simplifying process harder. So it's best to just leave the bottom factored. The top, however, we have to expand, because the top is not expressed as a product, right? It is expressed as a difference. We're subtracting a couple of products. So to simplify, we're going to expand these products. So we have ax plus a, and then minus ax plus a. Being careful with my signs here. All over x plus 1, x minus 1. And now we can combine like terms up top. The ax minus ax, those cancel. A plus a is 2a. And so that's our final result. 2a divided by x plus 1, x minus 1. All right, let's try another one. Again, we can see that we're not starting out with common denominators. We need to get a common denominator. In order to figure out what that common denominator is, we need to make sure all of our denominators are factored. In all of the examples before, our denominators were already factored. But this denominator here can be factored. So I'm going to start by rewriting the problem, leaving myself some space. And that last denominator can factor as x times x plus 1. So the least common denominator has to include all the factors that I see. Sometimes it can be helpful to write out what we think the LCD is going to be. So if I'm going to get all the factors that I see written here and nothing extra, that means I need the 2x, I need a factor of x plus 1, and then that's sort of, I go through making sure that I have this and that I have that. And by the time I get to this one, I realize, well, that's already represented here. So I don't need to add anything more. So that is what our LCD is going to be, which means that should be our denominator in the end. To get to that LCD, that least common denominator, this first fraction has to pick up a factor of x plus 1 on the top and the bottom. The second fraction needs to pick up a factor of 2x, or a factor of 2 and a factor of x, I guess. And the last fraction just needs a factor of 2. So let's start this process. Okay, so and in fact, maybe what I'll do is do this over here. Go bring this over here. So my denominator is 2x, x plus 1. Up top, I have the product x minus 4 times x plus 1 plus 2x times x plus 2 minus 2 times 3x plus 2. The bottom is factored, which is beautiful. I want to leave it that way. The top needs to be expanded out so I can combine like terms and determine if we can simplify further. So I'm going to FOIL this out. I'm going to distribute that 2x, and I'm going to distribute that negative 2. So let's see, let's begin with this first product. If we're FOILing that out, that'll be an x squared minus 4x plus x is minus 3x, and then minus 4. In the middle, now we're going to distribute the 2x, so that's plus 2x squared plus 4x. And at the end, we're going to distribute that minus 2, so negative 6x, negative 6. So now we've expanded everything. Let's combine like terms. So x squared plus 2x squared is 3x squared. Negative 3x plus 4x minus 6x is minus 5x. And then negative 4 minus 6 is negative 10. And then the last thing we want to do is check to see if we can factor that trinomial up top. So I'm not sure if it factors yet. I'm going to kind of just play around with it. If it factors, we need a 3x and an x. And this negative 10 could be a 10 and a 1 or a 2 and a 5, and I know those signs would have to be different. So let's see. Minus 2 plus 5, that would be an overall negative x, so that doesn't work. Minus 5 plus 2, that's negative 15 plus 2 is negative 13, which doesn't work. And let's see. Let's try plus 10 minus 1 is plus 10x minus 3x, which doesn't work. And certainly putting a 10 here won't work because that'll give a 30x, which we're never going to make into a negative 5x. So I believe that this does not factor. And that means that this is as far as we can go. All right, to finish up, we're going to take a look at complex fractions. And there's more than one approach that we could take with these. One is spelled out here, where we just simplify the numerator and denominator separately, like treat them as their own problem, and then we are left with dividing two fractions. And we know how to divide fractions. So I'm gonna do this example using that technique, and then we'll do it again using another technique. And both of these techniques will be equal. They'll both always work. It's really just a matter of personal preference. So we need to figure out what we have on top and what we have on the bottom as a single fraction. So up top, we have 1 minus 1 over x. That's 1 over 1 minus 1 over x. And if we get a common denominator of x, this is x minus 1 over x. On the bottom, we have x minus 1 over x squared. So that's x over 1 minus 1 over x squared. And this ends up being x cubed minus 1 over x squared. So now let's proceed. We know how to do a problem like this. We're going to turn it into a multiplication problem. And almost everything is factored, except we can factor that difference of cubes. So that's x minus 1, x squared plus x plus 1. And now we can cancel what will cancel. There's the x minus 1. And x cancels with one of those factors of x, and we get x over x squared plus x plus 1. So that is one technique, simply to attack the top and the bottom as separate problems and then do the division problem when you're done. The other method, I guess I'll just call this method number 2, is to multiply the top and bottom of the fraction of the, I guess I'll call it the big fraction, by the least common denominator of all the small fractions, like all the small fractions that appear within the big fraction. Alright, so I'm going to begin here just by rewriting the fraction 1 minus 1 over x divided by x minus 1 over x squared. Now, the LCD for this fraction, for all the little fractions that appear in it, is x squared. So I'm going to multiply the top and the bottom by x squared. And when I do that, I'm going to have to distribute that x squared to each of those terms. Now I'm going to write out that distribution. Sometimes people will distribute and reduce or cancel as you go, and that's fine. I've got 1 times x squared minus 1 over x times x squared. In the bottom, I have x times x squared minus 1 over x squared times x squared. So now I'm going to just simplify each of these products, that appears. Up top, I have x squared minus 1 over x times x squared is x. On the bottom, I have x cubed minus 1. And now I can simplify this fraction by factoring. Up top I could take out an x times x minus 1. The bottom is a difference of cubes. X minus 1 times x squared plus x plus 1. We see that the x minus 1's cancel, and we are left with x over x squared plus x plus 1, just as before. So these two methods, they're equivalent to each other. They both will always work. It's really just a matter of personal preference of how you want to go about simplifying complex fractions. We're going to end with this example here. And it might not at first look like a complex fraction, but you'll notice that there are negative exponents, and negative exponents are fractions. So when I look at this, it's almost like somebody's trying to be sneaky and hide the fact that they have fractions within fractions, which is not simplified. But I see right through that, so the first thing I'm going to do is rewrite it as the complex fraction I know it is, 1 over x plus 2 over y squared over 1 over x minus 2 over y squared. The LCD, the least common denominator of all the little fractions, in this complex fraction is xy squared. So I'm going to multiply, I'm going to choose the second method. I'm going to multiply top and bottom by xy squared. And I'm going to distribute. And as I distribute, I'm going to do the simplifying. So 1 over x times xy squared is y squared. Plus 2 over y squared times xy squared. Well, the y squareds will cancel, and we get 2x. In the bottom, 1 over x times xy squared. The x's will cancel. I get y squared minus 2 over y squared times xy squared is 2x. And this is as far as we can go. We cannot cancel over addition or subtraction, so this is as simplified as it gets.